All right, this one's actually number 3. The last one I said number 3, but it was number 2. The function f of x equals 1500 times 0.95 to the power of x, where x is time in years, models a prairie dog population. Is this function an example of exponential growth or decay? The r value is 0.95. And this r value is between 0 and 1. So this will be an exponential decay. It's because it's like a repeated division. And B, how will the graph of this function compare to the graph of f of x equals 0.95x? How do you know? This function will be much steeper because there is a vertical stretch by a factor of 1500, and the y-intercept will be 0, 1500. C. Use your calculator to create a table of values and a graph of this relationship. So, since this is the time in years, we're not going to have negative years. So we're going to start, we're going to look at the table starting from when x is 0. But in our calculator, we're going to go to y equals, and we're going to put 1500 times 0.95 to the power of x. And then once that's in your calculator, this time you're going to press second graph to get to the table. So in our table, we're going to look at when x is 0, 1, 2, 3. Then we could look at when it's 5, and then we could look at when it's 10. So when x is 0, the y is 1500. After 1 year, there's 1,425 dogs. After 2 years, there is 1,353.5. After 3 years, there's 1,286.1. After 5 years, 1,160.7. And after 10 years, 898.11. So then for the graph, we need to go all the way up to 1,500. So I'm going to go by 500s. And this is prairie dog population. How do you spell that? Prairie dog population. And this is years. This is time in years. So we don't have to graph all this perfectly, but it starts up here, and then it's going to slowly decrease. Okay, and it looks curvy. It should be like a curve. This is not a good graph. I'm so sorry. Bad graph, Miss Monday. Okay, D says, what is f of 0 and what does this represent? F of 0 is 1,500, and that means that the initial population is 1,500 prairie dogs. E, what is the growth factor? So the growth factor is 0.95, which means that this is actually decaying. F, by what percentage is the prairie dog population changing? It is decreasing by 5% each year. G, how many prairie dogs will there be in 8 years? So we could do this a couple ways. We could look at our table, we could look at our graph, but I'm going to say I'm going to go to our function and plug this into our function. So to the power of 8, and so after 8 years, there is 995 prairie dogs. H, if the equation changes to 500 times 0.095 to the power of x, what impact does this have on this scenario? So the initial population will be 500, and the graph will not decrease as quickly. Remember, the larger the a value, the faster it decreases or increases. And I says if the equation changes to 500 times 1.05 to the power of x, what impact does this have? So what changed is the rate, and the rate, the b value is now bigger than 1, so this will be an exponential growth because the b value is 1.05, so it's an exponential growth by 5% each year. All right, I hope this helped. Have a wonderful day.